Hello, and welcome to our talk on securing analytics. My name is Scott Ellis. I'm a product manager on our data security and privacy team. Let's get started. Today, we're going to cover the importance of data security for analytical workloads. And then we're going to look at some real-life scenarios where we apply data security using some of our tools like Cloud DLP and BigQuery. Then we're going to take a quick look at our additional capabilities of our DLP security platform and kind of an overview of how the technology works. Let's get started. So analytical workloads are critical to your business. They can help you understand and optimize your business operations, gain insights into your business and your customers, maybe you build some innovation into your services, or help you conduct critical research or improve customer support. The key thing is that analytical workloads are powered by data. And what we're going to talk about today is how to protect that data and secure that data in various analytical workloads. And first, let's talk about some of the core principles of data security. And we kind of bundled it down into these four. So the first is really the goal of collecting and using data properly. So maybe you're collecting data, processing it, storing it, or sharing this data. You want to make sure that you're doing it properly and following all of the requirements and regulations that you need to. And as part of this, one goal is the second one here is to reduce risk. And you might think of this as something like least privilege or need to know. The idea being, how can you minimize the amount of sensitive data that you're sharing or using for a particular business process to only that data that's critically necessary to complete the task or complete the operation. And through all this, you want to make sure the third bullet of enable the business. You have to make sure that your data security and privacy is there, but that you're also able to operate and provide a valuable service to your customers. And through all this, you want to make sure you're accountable. So this means being able to audit, being able to demonstrate that you're doing this, and wherever you can, be able to automate these processes so you can have that control built into your workflow. Now, before we get started and get deeper into this, we wanted to kind of bring up one topic here, which is when you're dealing with analytics workloads, you're not always dealing with well-structured and well-formed data. In a lot of cases, you're dealing with unstructured data. And in the example that we have here, we're seeing what we call free text or natural language data. This is a human typing information in sentence form, and this information may contain sensitive information, and we need to be able to handle this as well. And in this case, again, it's not necessarily structured, it might be unstructured data. So we want to make sure our data security can handle both structured and unstructured. We'll get into more details on this later, but I just wanted to bring that up at the beginning. So let's look at some real life scenarios of how we can apply data security and privacy to our analytics workloads. And for this, let's meet Angie. So Angie is a data compliance officer for a large online retailer, and they serve customers across the globe. And Angie is in charge of compliance and security across all departments. Now, the first scenario we want to look at here is how can we apply data security for our data warehouse or analytical data warehouse? And in this case, Angie's company has decided to use BigQuery to power all their data analytics. But they want to make sure that while they have this business momentum that BigQuery provides, that they also have that with the proper governance and audit of all their data security and sensitive data. So the first question Angie has is, how can I gain visibility into the sensitive data in my analytical data warehouse? Now, we mentioned that Angie's company is big. They serve customers across the globe. They have a lot of employees working with data, a lot of systems working with data. So they need a solution that's automated. So here, Angie uses Cloud DLP to inspect and discover sensitive data across their warehouse, and then use those insights to automatically tag sensitive tables and columns. And the outcome here is that Angie's team can now use those insights to make more informed decisions about how their data is used and how the data is protected. Now, next question Angie has is, how can I enable more fine-grained access control and protection? So now that we know where sensitive data is, how can we apply it so that we actually get better access control and better security? So for this, we're going to use column-level access policies. And something called BigQuery policy tags enable column-level policy enforcement that can help strike a balance between granting access while also protecting data. So in this example here that we're seeing, Angie has set up a data security policy that breaks data down by categories like financial, health, and maybe general PII. And then we're going to use that data security policy along with the insights we learned from Cloud DLP to actually tag the columns and apply this enforcement. So as you see here, we have a table where we've applied this column level access policy to some of the fields, some of the columns in the table. And what that means is that if you have access to this table, you may only have access to some of the columns and not others. So for example, someone who has access to the ID field and the payment type and the transaction amount could go in and run aggregate analysis, maybe average transaction amounts or count the number of transactions, but they wouldn't get access to the sensitive information like name, email address, or payment card information. For that, you would need extra access. And this again is an example of how we can have multiple people accessing data, but have that finer granularity of access control for the extra sensitive elements. Now, the second scenario we want to talk about is how can we protect machine learning workloads using techniques like de-identification. So the first idea of knowing where sensitive data is kind of the first step of protecting it. And we covered that just now with the last scenario, discovering the data, tagging it, and then putting in access control and enforcement based on those tags. But what if you can also go in and remove data or obscure it using techniques like de-identification? And that's another technique that you can use to help you meet some of the core goals around things like least privilege, need to know, and again, things like data minimization. The idea here being minimize the amount of data that you're sharing or exposing to just that's critically needed. Let's go and look at an example of this. So first, Angie has the question, how can we redact sensitive information from our machine learning and AI workloads? Let's consider this example. So here we're looking at unstructured data. In the upper left-hand corner, we have a note that was typed in that has sentences, and it's unstructured. In this note, we have different types of sensitive information like personally identifiable information or PII, some healthcare medical data, a medical record number. There's a lot of information in there. And because this is unstructured, what it really needs is a combination of inspection and masking to be able to handle this. And we need that to work together in one platform. So to show what that looks like, if we look at the bottom left, after DID, what we're seeing here is we've actually gone into that unstructured data, identified sensitive elements, and removed them. We've replaced them with terms like what type of data it is, like person name or phone number or date of birth. The key thing here is we've removed the sensitive elements, but we've left the context, the sentence structure, and the rest of the data intact. And that's one way that we can protect this data through obfuscation. Now, another question Angie has is, how can we retain integrity in our data while also de-identifying it? When we talk about integrity here, we mean the ability to maybe join data or run aggregate analysis where you need to have an identifier or some integrity that you can actually still run your analysis on. So for this, Angie's going to use Cloud DLP again to configure which fields, which bits of the data to tokenize and which bits to redact. Tokenization in this example will allow Angie and their team to retain some of that integrity. So you can still join tables, you can still run a lot of that analysis, whereas redaction can help with some cases where you just want to completely remove that value. Let's look at an example. So imagine we have these two tables. We have a table of notes on the top, and we have a table of ratings on the bottom. Now, by looking at these tables, we see that they both have a column called email account, which contains an email address in it. And what we really want to do is we want to join these two tables so that we can look at the basically the notes field and the ratings field and analyze those together. But we don't want to expose that email address. So what we're going to do is we're going to de-identify those tables by converting that email address into a token. So what we have now is a tokenized version of that email account field. We've also gone into the notes field and tokenized sensitive data that we found there. The key thing is that we can still join with tokens. Basically, what we can do is the same kind of join we would have done in that original email account, we can now do with the token because it keeps that referential integrity. What this allows us to do is join these tables into one so we can see the ratings next to the notes and conduct our analysis. So this is done without exposing that sensitive PII. Now, additionally, in addition to joining this, Angie's team can now unblock additional analysis such as machine learning or sentiment analysis. As we see here, taking that unstructured data in the notes field, even though some of the values have been tokenized, we can run it through a sentiment analysis algorithm and still get the right answer out. And again, this is a key thing to do where the analytics are still enabled, but the sensitive data is removed. So we've had a better data security and privacy posture. Now, data security and privacy is an evolving area. But what we've seen here in these few scenarios is that Angie's company, using our platform with DLP and BigQuery and other tools, Angie's company can make more informed decisions about their data and how to protect it. They can ensure data minimization and an improved privacy and security posture. And they've actually been able to unblock analytics and machine learning workloads while minimizing the risk of exposing that sensitive data. So we've seen some of these tools in action. Now let's dive a little bit deeper into some of the capabilities. We talked about our cloud DLP or data loss prevention platform. One of the core capabilities of this platform is to be able to discover and classify sensitive data. What that means is that you can leverage over 150 built-in classifiers to look for things like personally identifiable information or PII, as well as things like credentials and secrets, or even classify documents as sensitive. This can also be customized to meet your company's needs or your workload needs. Another capability of DLP is to measure privacy risk in what we call quasi-identifiers. Now, up till now, we've talked about removing sensitive information, and we've primarily talked about what we might call a direct identifier. If you imagine someone's email address or phone number, usually ties directly to a single person or entity. When we talk about quasi-identifiers, these are things that may or may not identify someone. So if you think of demographic information like age or location or job title, those generally don't identify someone, but they could if they're only held by a select few people. And that's what we're measuring here when we talk about privacy risk. So if you look at this example here on the left, we have a table that has two demographics, age and job title. And what we want to ask is, are there combinations of age and job title that link to only one person or a small group of people? Because if they do, then revealing those demographics could actually lead to a re-identification of that person. What we're seeing on the right is a visualization of this across our data. And we've selected a threshold of 10. And what we're seeing is the statistics and examples of age and job title combinations that link to fewer than 10 people. So maybe 9 people share that age and job title, or 8, or all the way down to 1 person sharing it. And this kind of analysis can help you identify statistical anomalies and risks that may be in your data in, again, these demographics and quasi-identifiers. The other capability we talked about is something we call de-identification. Sometimes this is referred to as data masking or anonymization, but really it's a collection of techniques to help remove identity or blur or remove sensitivity from data. And what we're seeing in this before and after table is we're applying various techniques. So in that first column, we're using that tokenization technique that retains referential integrity, but it removes the original raw identifier. And that allows us to do things like joining tables or aggregate analysis. In the second column, where we have a job title, we're doing something called generalization or bucketing. We're actually taking something more distinguishing like a VP of engineering, and we're blurring that to something like engineering. And that allows us to address some of those cases we just talked about, where a group may map to fewer people. By generalizing some of the demographics, you can have that data map to more people. And in the last column, we're showing that combination of inspection and masking by looking through the comment field and identifying just the sensitive elements and removing those. In this case, things like email, phone number, and social security number. Now let's just put all this together again. So imagine we have a table that has columns like a user ID, in this case, it's an email address, maybe some date information, and some unstructured data. So when we apply de-identification, maybe we'll tokenize that user ID so we can use it as a join key. We might shift the dates so that we can get different dates but still have the same kind of duration and properties of the original dates. And then maybe we're going to redact that unstructured data. The key is, once we've redacted this information, we can still go query it. So this is an example of a simple query in BigQuery. And you'll notice in this SQL statement, we're not doing anything unique or new. We're actually running the same statement you could run on the raw data, the original data. And we're actually getting the same kind of result you would expect to get. The difference is that we're not exposing that raw email address. Instead, we're exposing this token, which is an obscured sensitivity. But an analyst is still able to look at things like who contacts us the most frequently, what's the average amount of transactions happening here, or other analysis they might want to run. And bringing back to that original example that we showed, where we had someone typing data in real time, this unstructured example, that's also something our DLP platform can support. There are cases where you may need to inspect data while it's being typed or while it's being maybe collected and before you persist it, or maybe before you display this data. And so our DLP platform can support these near real-time cases. And because it's a fully managed service, it can also scale for you to handle large-scale real-time or large-scale batch workloads. Now, let's dive a little bit deeper on how this technology works. And to start, let's look at the life of a DLP content request. So in this example, what we're showing in the upper left-hand is a simple request coming in that contains unstructured data. And that's going to be sent into our DLP API. And that transaction is going to be encrypted in transit. It's stateless, which means you can parallelize these requests for scale, but it's also not persisted. This information is returned in a synchronous fashion. We also have data residency controls, so you can control exactly where this is processed. Now, the response coming out in the lower left-hand corner is what we asked it to do. We said, can you please return a redacted version of this input? And that's what we see here, is we see the context and the sentence in place, but we've redacted that sensitive credit card number. Now, all of this infrastructure also goes through compliance audits. We've listed a couple of those here, and you can find more at cloud.google.com/security/compliance. Now, being an API means that you can plug this into virtually any workload, whether it's running on Google Cloud or otherwise. You can use it in real-time scenarios, you can use it in your own code, or you can run it through traditional ETL and migration pipelines. It gives you a lot of control and power. But sometimes you just want to go in and do something simple like edit a config, or maybe scan a cloud storage bucket. And so we also provide a console UI that allows you to do these kind of tasks. And what we're showing here is we're running a scan of a bucket that powers our company's website. And we want to make sure that there's no sensitive data in that bucket. So we set up a simple scan. We talked briefly about the regional endpoints, but the key thing here is you can control the data location and the regional, where your data is processed from a regional perspective. And this allows you to have data residency. Maybe you want your data to be inspected and tokenized in Europe or in Australia or in Canada or in the US. You can control where it happens. You may also want to do this for high availability reasons, where you can control exactly when and where things fail over if you need to. So we provide that control so you can take control of where your data is processed. And also, we covered a lot of exciting things that we do today, and we're constantly making that better. So some of the things that are coming soon are the ability to profile your data across entire orgs. We're making that easier to do to allow you to really get insights across your entire BigQuery footprint or your entire analytics data warehouse here. And so look for more of this coming soon. And with that, we'll close this talk with a few key takeaways. The first is protecting sensitive data really starts with discovery and classification. You can use that again to set access control policy. And next, using de-identification can help you obscure sensitive elements while preserving context and utility. And our Cloud DLP security platform offers a lot of these capabilities as a scalable, flexible service that's fully managed. So you don't have to deal with deployments or manage operating system updates or anything like that. To learn more, visit us at cloud.google.com/DLP. And thank you for your time.